8th graders, today's lesson is 2.3 and 2.4 thermal energy, and your learning targets are: I can explain how energy transfers in a system until equilibrium is reached. So what we're really focusing on today is zooming in to an object on that molecular level and looking at its energy, how the molecules move, and then considering if we were to make that object come in contact to another object with a different temperature, how would those collisions of molecules cause energy transfer, and what would that look like at the end when we reach equilibrium or when both objects all have the same kinetic energy? All right, so very first step today is you guys are going to open up your OneNote, and you guys are going to add key concepts 5 and 6 to your OneNote. Mine's being a little slow loading today. You can see 5 is adding, 6 is loading, but what that should look like is when two things are in contact, their molecules collide, and kinetic energy transfers from the faster moving molecules to the slower moving molecules. And we've really talked about this in terms of moving energy from a hot object or a warmer object to a cooler object. Energy is not created or destroyed. Therefore, as energy transfers, it increases in one part of the system as it decreases in another part of the system. So that's key concept number 6. We can't just have energy pop out of nowhere and be present in an object. It has to come from somewhere. So there has to be some kind of energy transfer that facilitates that. And then finally, change, stability, and equilibrium need to go into your vocab. So change is when something becomes different over the time. I think you guys pretty much know that one, but we can throw it in there. Stability, when something stays mostly the same over time. So when we're talking about equilibrium, we're going to be talking about that system being stable, meaning we don't see much of a change from the beginning to the end. And then finally, equilibrium is a balanced state at which a system is stable, such as when 2 or more samples are at the same temperature. So we might look and say they're the same temperature, or we could look in and zoom in on those molecules and see that they all have the same kinetic energy after a time. All right, part 2 is your warm-up for today. So you guys have this picture where we have sample A coming into contact with sample B, and this arrow shows us the energy being transferred from A to B. Okay, this graph shows the temperature graph for sample A, so we can kind of see that our y-axis is the temperature in degrees Celsius, and our x-axis looks like time because we're talking about temperature over time. So it looks like we started off just shy of 100 degrees, which is almost boiling, and then it looks like we came down and our line kind of flat-lined here at about 50 degrees Celsius and stayed the same. Okay, so your question asks you, what does the graph tell you about the temperature of sample A over time? So what did we see happening? I just talked about that with you. And then what can you infer about the temperature graph of sample B? Okay, so we can see that sample B was getting energy from sample A when they came into contact. So what do you guys think that graph would look like? Okay, would it look like A, or would it look slightly different? Okay, and how do you think it would look? All right, moving on to part 3, little simulation for you guys. So what we're going to be looking at is 2 claims in this simulation, and you're going to test them out. So this really relates to our key concept 6 that you guys added to your notebook today. So simulating temperature change. Obviously you don't have a partner, so continue to use the sim to gather and record evidence about the claims. So why do molecules change speed? So claim 1 states that molecules speed up when energy is created and slow down when energy is destroyed. Okay, versus claim 2, molecules speed up when they get energy from other molecules and slow down when they give their energy to other molecules. So you guys are going to test what actually happens with those claims. So here's your sim. You guys are going to go ahead, right click, and open that link. And you guys again will be in the simulation right here. Your directions say to launch the sim. If you each have a device, display these instructions on the other device. You guys are working by yourself, so you guys can just kind of bounce back and forth between this page and your sim. Add 2 samples of the same size. In run, press the view kinetic energy and the energy transfer toggle. So we're going to go ahead and add 2 of the same size. Really doesn't matter what size you use. And we're going to go up here and say, here's our kinetic energy toggle and our view energy transfer. Okay. Press the plus or minus buttons to add or remove energy so that the sample is warmer and the other sample is cooler. So we're going to heat one up. You guys can see as I heat it up, looks like we're using a little coal there. That arrow shows us the energy being transferred into that sample. Think about what happens to our molecules once that happens. And then if we cool this down, we see that the arrow goes in the opposite direction. It actually points from the molecules into the ice, so energy is being transferred from our sample into the ice. Okay? Drag the two samples together and observe what happens. I'm not going to show you this part. I'm going to have you guys do that on your own. Open Analyze. You guys will see a graph when you see Analyze. Okay, right now you guys can just see this, but we haven't pushed them together yet, so you can go back into Run and still do that. And then replay the sim and observe what happens on the graph after the two samples are dragged together. So you guys won't be able to see that on the graph yet. This would be kind of this part over here where we drag them together and see what happens. You guys can see sample A and sample B. You guys can turn off and just look at one line if you choose. Okay, so this is the point at which I heated up sample A with the coal. I stopped to talk right here. And this is the point where I lowered the temperature of sample B using the ice. Okay, so you guys can kind of see how they relate to each other, temperature over time and thermal energy over time. So you guys can see how those are related as well. All right, and then build on any evidence you observed during the warm-up and complete the sentence on the next slide. Be sure to mention evidence from both Run and Analyze. So what evidence did you gather about the claims? Okay, so think again to your claim 1 saying that energy is created and it causes the molecules to speed up and move, or when energy is destroyed, it causes them to slow down, versus claim 2 saying that, you know, when objects are speeding up or molecules and objects are speeding up, it's because they're getting energy from something else, and when they're slowing down, they're giving their energy to something else. So do you guys support claim 1, claim 2, or do you guys think there's some support for both claim 1 and claim 2? So use your guys' draw tool to circle your answer there, and then move on to the next slide. Okay, just as a reminder, do you guys remember anywhere you guys see this little question mark on your slide, there's something you guys need to do on that slide. So take, for instance, this next slide. We have some directions, but it looks like we also have a data table to fill out, and we know that because this question mark is there, and there's a data table that's empty. Okay, so open the simulation, add two samples of equal size, turn on your view kinetic energy toggle, so we can see if we can maybe do this from our other sim. Make sample A much hotter than sample B. You guys already have that taken care of. And then record the starting temperatures of both samples in the table below. So you guys can see where your temperatures are at right now. This one is at boiling, 100 degrees Celsius, which would be 32 degrees Fahrenheit, or excuse me, 212 degrees Fahrenheit. And then this one is frozen. It's at 0 degrees Celsius or 32 degrees Fahrenheit. Okay, so you guys can record your samples there. And then you guys are going to go ahead and push the samples together, wait until the energy stops transferring, so allow that energy to transfer back and forth as need be, and then record your final temperatures here. Okay. All right, moving on. Before coming into contact, the molecules of sample A had more kinetic energy, less kinetic energy, or the same kinetic energy as the molecules of sample B. So use your draw tool to circle one of those answers there. Once the energy stopped transferring, so this is after we push them together and let the energy move back and forth. Once the energy stopped transferring, the molecules of sample A had more kinetic, less kinetic, or the same kinetic energy as the molecules of sample B. So again, use your draw tool to circle one of those three choices to fill in the blank. Moving on, before the samples came into contact, the temperature of sample A was higher than, lower than, or the same as temperature of sample B. So again, use your guys' draw tool to circle one of those three options for the blank. And once the energy stopped transferring, the temperature of sample A was higher than, lower than, or the same as temperature B, or temperature of sample B, excuse me. So use your draw tool there as well. All right, moving on, last little part of the sim is switch to Analyze and scroll back to the beginning of the run. So you guys, again, would go to your Analyze. You guys would click your little time frame, and you guys can go back to the beginning of this. Okay, focus on the thermal energy graph. So that's going to be your top graph here. And then scroll forward, record the total energy of the samples after you made one hot and one cold. So if we look at this, you guys can see the point at which I made one hot. So here we started to make it hot. Here's one hot. Here's my sample A, and then my cold came a little bit further away. There's after I made one cold. Okay, so you guys can record those. And then record the thermal energy at the end of the run. So obviously you guys would need to push those together to see what happens. So you guys will scroll to the end and tell me what happens to the thermal energy there. Notice there isn't a change from our beginning because we haven't pushed those two objects together yet to let energy move back and forth. All right, so fill out your table there. And then last little question for you guys to answer as far as your multiple choice. So the thermal energy of sample A, use your draw tool to circle increase, decrease, or stayed the same, and the thermal energy of sample B either increased, decreased, or stayed the same after contact. So we're looking at what happens after we push those two together. And then why did the transfer of energy between the two samples stop? I really want you to think back to what we talked about with our learning target for today. Okay, our vocab, those kinds of things. There's one specific word that I'm looking for in your answer. So use that to help you guys answer and explain why that energy transfer stopped. Okay, and then finally, you guys have a little reflection piece to do. So you guys see system 1, system 2, system 3, system 4. The diagram shows kinetic energy of different samples that are not yet in contact, but that may be in contact in the future. With your partner, you guys are working by yourself, predict what will happen in each system should their samples come into contact. So if we have sample A is obviously the cooler sample here, we can see the temperature, versus sample B, we can see that temperature, and then also the thermal energy. If we were to push those two together, what do you think would happen? Okay, think of which direction energy transfers. Is it from your cooler to your hotter to the cooler, or is it random? Okay, same with this one. We have sample 2. It looks like they're the exact same temperature. So what would you expect to happen with their thermal energy transfers? Again, same temperature for sample A and B. System 4, I'm going to let you guys figure that one out. Okay, so in your reflection, select the system, so you might have more than one option there, below in which the samples will change if they come into contact. Select all that applies. So you guys will use the draw tool for this and circle any of those systems that you guys think will have some change, okay, if we push them into contact with each other. Finally, do your wrap up for today. Any questions, circle yes or no. If you guys have any questions, type them in right here. If you guys have any questions that are preventing you from finishing this assignment, let me know right away and I can help you out. And then finally, 4, 3, 2, 1, how do you think you did on this assignment? Circle that. And you may go ahead and hand it in. I hope you have a wonderful day and I'll talk to you soon.